This video is for section 3.3 in the textbook, and this is about solving equations that have variables in the exponents. So one of the equations we'll look at is something like 2 to the x power equals 9. So you can see we've got the variable up in the exponent, and the question is, how do we handle something like that? Okay, so what we're going to do is we're going to use what are called properties of logarithms. So let's review what we've talked about in relation to logarithms. We say if b to the x power is some number m, then we can say that the logarithm to the base b of m is equal to x. Now notice that the logarithm is the exponent, what was the exponent in the original statement. And so these properties of logarithms that we're going to talk about are really nothing more than the rules for exponents. Okay? And in particular, the rule for exponents that we're going to talk about today is where if we say, let's say, b to the x raised to the y power is b to the x times y, right? If you raise a power to a power, then you multiply the exponents. So I'll move that over here, give myself a little bit more room. Okay. Now the logarithmic way of saying that is that if we take log to the base b of m to the p power, that's going to be p times log to the base b of m. All right? So this brings the exponent down in front as a coefficient. And that's why it's helpful in solving those problems where the variable is in the exponent, is because it brings it down as a coefficient. So let's take a minute to talk about why this is true. Okay? What does it have to do with this right here? So first off, we'll start with a logarithm, log to the base b of m equal to some number of x, it's some number x, and that means that b to the x power is equal to m. So that's just what we had over here. Okay? Now, this part down here, we're interested in m to the p power. So let's raise both of these, both sides of this equation to the p power. So there's m to the p power, and this is b to the p times x, right? This is where when you raise a power to a power, you multiply the p times the x. Okay, so now we come back to the question of what is log to the base b of m to the p power, and how is it equal to this? Well, we have to understand, what is this saying, or what question is this asking here? When you write a logarithm, what you're really asking is, what power do you have to raise this b to get m to the p, right? If you look over here, the power that we raise b to get m is x, and there it is as the power. And so this is asking the question, what power do we raise b to get m to the p? Here it is right here. Raise b to the p times x power to get m to the p. Okay, now go back and look at what x was. Log to the base b of m. So that is the property of logarithms that we're going to use in solving these equations. Okay, and that'll allow us to bring these exponents down and work with them numerically in a way that we really would be difficult otherwise. Okay, all right. So I'll leave this up over here, and you'll see how we're going to use it to solve these equations. So these problems are on page 167. Okay. And we'll start out with problem 2, which says 2 to the x power equals 9. Okay. So first off, let me just remind everybody where the key aspects of what we're going to be doing are on the calculator. So let's get the focus here on the calculator. There we go. And then what we're going to be using is right there. You see the log key, that's log base 10, and there's the ln key, that's log base e. Okay, so we're going to use those to solve these equations, and I'll show you a little bit more when we get to that point. So here, let me write these down. We're going to use log base 10 or log base e. We can use one or the other. The key is just once you choose one, stick with it. Don't use both in the same problem. Okay? So let's see. In this problem, I'll use log base 10. And the idea here is that in the same way that you can add something to both sides, you can multiply on both sides, you can take a square root on both sides, we can also take the logarithm on both sides. So log base 10 of 2 to the x power should be the same as the log base 10 of 9, right? What we're saying is if these two things are equal to each other, their logarithms should also be equal. Now, what that does for us is now we can take this and use this property. That'll bring the x down in front as a coefficient. And then this log 2 is just a number, and we can divide on both sides by log 2. And so there's our x is log 9 divided by log 2. Now, we do want an approximation for this. We want to know, well, what is this number, you know? So let's take a look at how to do that on the calculator. Okay, let's see here. Okay, so we saw a few minutes ago how the log keys are over here. So we'll hit log. Now as soon as I hit log, notice how it automatically opens up a parentheses. So it's important to close that parentheses after we type in the 9, right? So we'll type the 9 in, and then we got to close that parentheses. And there they are, right above the 8 and the 9. So there's log 9. Now we can do divided by log 2. So there's our calculation, log 9 divided by log 2, and that gives us an approximate answer of 3.1699, or about 3.17. Now, something that people sometimes do is they don't notice that that parenthesis got open, so they just go log 9 divided by log 2. So look at the difference between those. See how in the second one, that first parentheses never got closed. I mean, even if we close the other parentheses right there, right? When I hit enter, this is going to be the wrong answer. This is a different answer, okay? So it is important when you're making these approximations to pay close attention to how those parentheses are working, okay? So let's see here. So this is about 3.170. All right, and that makes sense because 2 to the third power is 8, so it makes sense that a little bit more than the third power would give you 9. All right, that's problem 2. Let's take a look at problem 4. All right, so problem 4, I believe, says 3 to the x power equals 20. Okay, so I used log base 10 on the last problem. For this problem, I'll use log base e, or ln, natural log. So we'll say ln 3 to the x equals ln 20. And then we can use this property of logarithms, bring the x down in front here, and then just like the last problem, divide on both sides by ln 3. And so there's our statement of the answer, but let's get a good approximate value for this. So we'll do ln 20, close that parentheses, divided by ln 3, and this is about 2.727, okay? And we can check the answer if we want to. Let's take a look at it, all right? So there's our calculation, ln 20 divided by ln 3. And so if we want to check this out, we can do 3 raised to the 2.727 power. And there it is. Hit enter. And it's just about 20. We rounded that answer off, and so when we raise 3 to that power, we get about 20. Okay? All right. So that's problem 4. let's look at problem 6. That's a little bit different. All right, so problem 6 says 7 to the x plus 1 equals 41. Okay. Let's see. I think I'll use log base 10 here. We'll say log of 7 to the x plus 1 equals the log of 41. So now this whole exponent comes down in front as a coefficient. And notice I put it in parentheses because we're going to have to distribute that log 7 into the parentheses. Okay? So I'll do that. There's another way to do this. I'll come back at the end and do this a slightly different way. Okay? But for right now, let's just distribute the log 7 into the parentheses. So here's our x. So let's take anything that doesn't have an x and move it to the other side. So now we've got x log 7 equals log 41 minus log 7. And then we can just divide on both sides by the log of 7. So we get x equals log 41 minus log 7 all over the log of 7. Now, we want to know what is this number, right? I mean, it's going to be a little bit less than 2 because, well, actually, let's see. X should be a little bit less than 1 because 7 squared would give us 49, okay? But to find out what that is, we're going to need to do an approximation. And so again, let's take a look at this on the calculator. And again, we have to be careful of parentheses. Okay, so let's get the camera to focus. There we go. So we need to do log 41. Now what I often do is I do log 41, close that parentheses, minus log of 7. Okay? So there's our numerator. I'm just going to calculate this separately. Okay, there it is. And now if I hit the divided by key, right, divided by log of 7. And there's that right there. When I hit enter, we'll get a nice approximate value. And like I said, a little bit less than 1, 0.9084. Okay? Now, if you try to type this all in at once, okay, let's say we do log 41 minus log 7 divided by log 7. So what I've got there is not correct, okay? That the numerator is not in parentheses. This is not going to give us the correct answer. This is going to give us something else. That's not the correct answer, okay? If you want to calculate this all at once and get the correct answer, you've got to put parentheses around the numerator itself, right here and over here. So I'll type that in as well. And, you know, if you like to do it that way, that's fine. I just like to avoid all of these hassles with the parentheses. So there it is typed in correctly, and you've got the parentheses around the numerator and then divided by log 7, and there's our correct answer, 0.9084. So what I'm saying is, again, really be careful when you're going to approximate these answers. Okay, so our approximate answer here is about 0.9084. All right, now let's go back here and talk about a different way to approach this problem, okay? Because right at this point right here, we can hold on to these logarithms and come up with this answer, or we can approximate these logarithms right here. So let's see what happens if we do that. Log to the base 7, 0.8451 is a pretty good approximation. And then over on this side, log of 41, 1.6128. Okay. From here, the process is essentially the same. We're going to distribute this inside the parentheses, 0.8451x plus 0.8451. And then we're going to subtract this over to the other side. So we've got 0.8451x on the left-hand side. And on the right-hand side, we just need to subtract these two decimals. 1.6128 minus 0.8451. And we get 0.7677. And so now we just need to divide on both sides by 0.8451. And so let's see, 8451. And so 0.90841. Okay? So again, pretty close. Pretty good approximation. And that's why it's important to make good approximations when you're at this step so that you don't lose too much accuracy and you get something that's in the same neighborhood as the actual answer. Okay? All right. We'll talk about that process more in the next problem. So let's take a look at problem 10. All right, so problem 10, 4 to the x plus 2 equals 5 to the x power. Okay, so let's see, I'll use ln in this problem. Ln 4 to the x plus 2 equals ln 5 to the x. Now notice that in this problem, we've got variables on both sides of the equation. So this x plus 2 comes down in front of the ln 4, and this x comes down in front of the ln 5. Okay, so I think this one, I'll do these approximations first and get an approximate answer, and then we'll go back and we'll look at what happens if we hold on to the logarithms and solve it that way. Okay, so let's see here. ln 4 is 1.3863. That's a pretty good approximation. And then over here, ln 5, 1.60944 times x. So this approximation I carried out a little bit further because I don't like to round if these numbers are in the middle here, right? So this was... you lose a substantial amount of accuracy if you drop this 4. It'll make it a lot more accurate to keep that in there. Just as a general rule, right, rounding up with these is fine, rounding down with these is fine. If you've got these middle numbers, I usually carry it out an extra decimal place. Okay, because it just preserves a lot more accuracy than if you try to round with these numbers in the middle. Okay, let's see here. So now we need to distribute. Distribute this into the parentheses, 1.3863x, and then do 2 times 1.3863, and that's 2.7726. Okay, let's get our x's together here. Subtract this on both sides. So those cancel out, 2.7726. And then we'll do 1.60944 minus 1.3863. And let's see. And that's 0.22314x. And so that's what we need to divide on both sides by 2.22314. Those cancel out. And let's see. 2.7726 divided by 0.22314. And we get x is about 12.425. Okay, now let's go back and look at what happened, what would happen if we held on to these logarithms. Okay, if we do the problem that way, we still distribute. We'll get x ln 4 plus 2 ln 4 equals x ln 5. And just the same way that we did in using the previous method, we want to get our x's together. So let's subtract x ln 4 on both sides. So now we get 2 ln 4 is x ln 5 minus x ln 4. Now, the problem here is that you've got x's in both of these, and you can't, it's difficult to put them together, okay? So what we're going to do is we're going to factor the x out, and that'll leave us with ln 5 minus ln 4, and then that's what we'll divide by on both sides. And so our exact answer is going to be 2 ln 4 divided by ln 5 minus ln 4. Now, approximating this also has its issues. All right? So let's take a look at this on the calculator and see what it looks like. Okay, so there's the calculator. So the numerator is not really a problem. We can just type in 2 ln 4. Now we got to make sure to close that parentheses, okay? So there it is right there. All right, so there's our numerator, and then we want to divide it by, and again, we need to divide by ln 5 minus ln 4. We need a parentheses for this denominator. So let's open a parentheses right there. Okay, there it is. And now we'll type in ln 5, close that parentheses, minus ln 4, close that parentheses, and now we need to close the parentheses for the denominator. So there it all is, and there's our 12.425. Okay? Now, the danger that we run into in doing this problem, now notice what I've just typed in there is missing those parentheses for the denominator, and as a result, we get a wrong answer. Okay? So again, really be careful when you're making these approximations with those parentheses. All right, let's look at one more problem here, problem 12. Okay, 6 to the x plus 4 equals 10 to the x power. All right, let's see. I've used both of these. Let's see. I'll use log base 10 again. Log 6 to the x plus 4 equals log 10 to the x. Then we can bring the exponents down in front. Now, let's see. We'll do this by approximation first, okay? So let's get a good approximation for log of 6. 0.77815. And notice I held on to that 5 because I didn't want to round up. It would be significantly less accurate if I did that. Over here, it's kind of an interesting thing. If you type in log 10 on your calculator, you get an answer of 1. Why? Well, remember what this statement asks. It asks what power do you raise this to get this number right here? Well, yeah, the first power. Okay, so that's why log of 10 is equal to 1. Okay, so now let's see, let's distribute, and we'll get 0.77815x. And then we'll do 4 times 0.77815, 3.1126. And now let's subtract on both sides. Collect our x's all on the same side. So 3.1126. So over here, you just need to do 1 minus this number right here. 1 minus 0.77815. 0.22185 x. And then that's what we're going to divide by on both sides. 0.22185. Okay, so 3.1126 divided by 0.22185, and our answer is about 14.03. Okay, so let's put that answer up here. Okay, now let's go back and solve this by hanging on to the logarithms and see how that works. Alright, so we'll distribute inside here x log 6 plus 4 log 6 equals x log 10. Now you could replace this with a 1 if you wanted to, okay, because log 10 is equal to 1. We saw that when we approximated it. But if we hold on to it, we're going to do the same thing. We collect our x's on the same side. And then factor out the x. Log 10 minus log 6. And then divide on both sides by log 10 minus log 6. And so we get x is equal to 4 log 6 divided by log 10 minus log 6. So let's make that approximation, 4 log 6, and then divided by log 10. And again, you could just type a 1 here. 1 minus log 6 would give you the same answer. And 14.03. Okay, so that's it for this video. Okay, we'll finish off the rest of the problems on page 167 in the next video. They get a little bit more complicated. So the assignment for this video is just going to be, let's see, what is it? Problems 1 through 11, and then we'll pick up with problem 13 in the next video. We'll see you then.